Very good morning to everyone. In this lecture, EC8652 wireless communication, third year ECE. Today we are going to discuss about the topic Unit 3 digital signaling for fading channels. Now let us move to the syllabus. So the Unit 3 digital signaling for fading channels. In this unit, we are going to discuss about the subtopics: structure of wireless communication link, principle of offset QPSK, and Pi 4 DQPSK model, and also the minimum shift keying and Gaussian minimum shift keying, and error performance in fading channels, principle of OFDM and cyclic prefix and windowing and peak average power ratio. Now the outline of this presentation. In the first session we have to going to discuss the structure of wireless communication link and also the modulation demodulation schemes and error performance and also the OFDM principles. Now we can move to the structure of wireless communication link. So this is a general block diagram of wireless communication link. The functionality of hardware units in a wireless communication link is discussed in this session. A simple structure of a wireless link. This is a simple structure. The main aim of this link is to transmit the information from analog source through an analog wireless propagation channel to the destination link. To increase the link reliability, digitalizing of information. If the information is in digital format, then digitalizing the technique is not required. The forward error correction coding is done in transmission to make the system more resistant to errors. At the receiving end, one or more antennas are used to receive the signals. So that is a multiple antenna may be used. To avoid the intersymbol interference, equalizer are used to receiver, which eliminate the dispersion effects. Now, what are the sequence of operations? Then transmitter, the steps are source coding and channel coding and modulation procedures, applying the multiple access, transmitting through the channel or media, and then the receiver reception steps, signal combining diversity technique, equalization, demodulation procedures, channel decoding, source decoding, and also the signal reception at a link. Now the source coder are used to redundancy in the source signal, and also it reduces the source data that has to be transmitted. For example, in GSM cellular standard, the source data rate is reduced in the form of 64 kilobits per second to 13 kilobits per second. This channel, the channel coder operand the redundant to protect the data from transmission error. Using the channel coding is GSM the data. The data rate is increased from the 13 kilobits per second to 22.8 kilobits per second. So what are the important? The important bit are given more protection. To break up the error burst, interleaving is done. The interleaving is more effective. It is combined with the channel coding technique, and then the signaling procedures add up the control information for making and terminating the connections. The signaling information is protected using the error correction coding. The multiplexer is used to combine the signaling and data information from many users. Multiplexing is increases the data rate from 22.8 kilobits per second to 182.4 kilobits per second in GSM. The baseband modulator assigned grass data bit. The baseband modulator make transmit symbol ready for transmission. In upconverter, the upconverter convert the analog filter signal to passband signal mixing with a local oscillator signal. The low noise amplifier amplifies the signal so that the effect of signal to noise ratio can be reduced. At the receiver, the down converter is used to convert the received signal. It is the base band. Now the signal is received and available as an analog signal. The low pass filter eliminates the adjacent channels, interference and noises. Once again we can move to the structure of wireless communication block diagram. The receiver down converter is to convert the received signal into the baseband. Now the signal is available as an analog signal. The analog to digital converter, the signal to digital signal carrier recovery, find the frequency and phase of the carrier of the signal received. The soft decision are obtained by baseband demodulator from digitalized the data. Then the symbol timing. The symbol timing recovery uses the demodulated information to calculate an estimation of symbol duration. The soft estimations are obtained by decoder unit from demodulator to find the original digitalized data. In conventional cases, decoder is simply a hard decision devices. For example, Viterbi decoder is one of the example. And the signaling recovery unit identify the part of the information that represent the signaling data, and also it control the demultiplexer. The source decoder will reconstruct the source signal from the source coding. If the source code is to send to digital to analog converter, that convert the signal to original analog from and to send towards the sync. Then the simply modified the circuit. What is the simply modifying the circuit? It is equivalent to the mathematical link model. For the wireless communication link, a simple mathematical model. In this model is more suitable for analysis the modulation methods and all the transmitter components from source to multiplier stage are infinite to keep the digital data. The source, the analog channels with the filters, amplifiers and up converters and also the down converters, etc. All the sub modules or the stages are equivalent time decreases low pass channel unit. The goal of this mathematical link is to analyze the modulation format. The parameters are used to judge the quality of the modulation format is the bit error probability. Then in this data link model, that is a structure of wireless communication link model, is a digital data source to digital data sink to transmit the individual analog signal to converted to the digital format and to communicate with the different baseband and passband transmission technique to recover the signal in error-free communication. Thank you for watching this video.